So let us now discuss the rest of the 4 types of reactions that are there in organic chemistry. So the third type of reactions that are there in organic chemistry, it is the elimination reactions. Elimination reactions. So with the name, it is very much clear that there will be loss of atoms or group of atoms from the molecule when we are talking about elimination reactions. So elimination reactions are again of 3 types, not like nucleophilic and all. It is alpha elimination, beta elimination, and gamma elimination. 3 types: alpha elimination, beta elimination, and gamma elimination. Now, when there will be an elimination reaction, there will be a loss of more than one atom or group of atoms. Okay, now if the position of the atoms or the group of atoms is same, that is both are on the same carbon atom and they are losing the molecule, then it will be known as the alpha elimination. So we are now starting it with alpha elimination. That is the atoms or the groups of atoms that are leaving the molecule, they are at the same position. For example, if we have this case, now in this case, there is loss of H positive. Then there is loss of Cl negative. And a carbene is formed. So this is carbene. So the formation of carbene is an example of alpha elimination. Both this hydrogen as well as this chlorine, which are leaving the molecule, they are present at the same position, right? Then next is the beta elimination. Beta elimination. So in case of beta elimination, the 2 atoms or the groups of atoms which are leaving the molecule, they will be present at the adjacent positions. So for example, if we have CH3, CH2, CH2, Br. So we have bromopropane, 1 bromopropane, and we are treating it with alcoholic KOH. So when 1 bromopropane will be treated with alcoholic KOH, it will undergo elimination reaction. Now this is the alpha, this is the beta position. Now bromine will go from this carbon and 1 hydrogen will leave from this position. So these 2 positions from where the elimination is happening, they are just adjacent to each other. So it will be known as beta elimination. So it is CH3, CH double bond, CH2. Okay, so this is beta elimination. Now we can take one more example to make it more clear. If I say this is CH3, CH2, CH, Br, then here it is CH3. Okay, now we are treating it with alcoholic KOH. 2 products are possible in this case. This will be the alpha carbon. Now there are 2 beta carbons. So there is the possibility of formation of 2 products. CH3, if hydrogen is leaving from this position, then the product will be this one. And if this hydrogen is leaving, then the product will be CH3, CH2, CH double bond, CH2. So this is known as beta elimination. The 2 atoms or the groups of atoms which are leaving the molecule, they are at the adjacent positions. Okay, the next one, the most important elimination is this one. Beta elimination. It is very important. Okay, so let us now clear the screen and move into gamma elimination. So gamma elimination. When the position of the 2 atoms or the groups of atoms which are leaving the molecule are at a distance of 3, then it will be 3 bonds distance is there, then it will be known as gamma elimination. So It is not very common type of elimination, right? So we are taking example. If this kind of situation is there, here is Br, here is again Br, alpha, beta, gamma. Now, if this will be treated with zinc dust, it will lead to the formation of cyclopropane with the loss of Br2 molecule, which will combine with zinc to form ZnBr. Right? So here we can say that this is leaving and this is attacking here. So leading to the formation of a cyclic ring. Not very important, not very common. Okay. Beta elimination is the most common and it is the most important one. Okay. So the next type of reaction. Okay. You can just clear these drawings. Next type of reaction is the rearrangement reactions. Rearrangement. Rearrangement reactions. In case of rearrangement reactions, what happens is, in the same molecule, under suitable conditions, a group of atoms, it will change its position and move to another atom. In the same molecule, a group of atoms or a single atom, it will change its position and it will move to another atom under suitable conditions. For example, if we have butane and we treat it with aluminum chloride, so this is N-butane, normal butane. It is treated with aluminum chloride and it will lead to the formation of isobutane. So this is isobutane. This is rearrangement reactions. Similarly, we can take one more example in which the double bond at the first position of but1-ene, it will be moving to the second position in the presence of acid catalyst, H positive catalyst. It will be CH3, CH double bond, CH, CH3, right? So this is but1-ene. This is but2-ene. Okay, so these are the two examples of rearrangement reactions. Then the next type of reactions, it is condensation reactions. Again, condensation reactions are also very, very important. Okay, the detail of these reactions, it is in aldehyde and ketone groups. So condensation reactions we will be discussing in short here. Fifth type of reaction is the condensation reactions. So what will happen in these type of reactions? An organic molecule, it will combine with another organic molecule. The two molecules can be of the same compound or they can be of the different compounds. They combine together, they may or may not lead to loss of some kind of molecule. Two organic molecules which can be of the same compound or two different compounds combine together with or without the loss of some simple molecule. Of some simple molecule. Simple molecule here means it can be water, it can be HBr, it can be HCl, right? So example here, the very important reaction is aldol condensation. That is discussed in detail in the chapter aldehydes and ketones. So we can take any aldehyde or ketone which is having alpha hydrogen. Again, you need not go into that detail here because that is to be discussed in that chapter. So it may lead to some kind of confusion. So you just can learn this example. So this is propanone and this is ethanol. Now, what will they do? They will undergo condensation. Okay, now this is 3-hydroxy, 3-methyl butanol. So 1, 2, 3, 4, 3-hydroxy, 3-methyl butanol. Okay, now this is the product. Either this can be the final product. Now, if this is treated with H positive and it is heated, in the presence of acid, if it is heated, it loses one water molecule. This OH group from this position and hydrogen from this position, it will leave. So this will be the product formed. Hydrogen from this position has left and OH from this position has left. Now this elimination is occurring at the adjacent positions. So this is beta elimination. This is again beta elimination. That is why I told you that beta elimination is the most important and it is most common. You will be encountering beta elimination the most. Okay, so here also beta elimination is taking place. Good enough. Okay, so the next type of reaction, the last type of reaction, that is the sixth reaction, is isomerization reaction. Isomerization reaction. So in this reaction, the one isomer of a compound, it gets converted into another isomer of the same compound, and there is no change in the molecular formula and there is no change in the carbon skeleton of the reactants and the products. The carbon skeleton of the reactants and the products is going to be the same, and the molecular formula is also going to be the same, both for reactants as well as products. Only new isomer will be formed. So for example, here we have trans-but-2-ene. When it is exposed to light and it absorbs energy, it gets converted into cis-but-2-ene. Now, what is carbon skeleton and what is the molecular formula? Molecular formula you all must be knowing. So if you count the number of carbons and hydrogens in the reactants and in the products, they're going to be the same. That is what we call as the molecular formula. Carbon skeleton means the length of the carbon chain is same. The substituents around the carbon chain, they are the same. Okay, so carbon skeleton is also same. Just the two isomers are interconverting from one to the other when it is treated with, it is exposed to light. So these are the 6 types of organic reactions. Now we know what are the different types of reactive intermediates. We know what are the different types of reactants. We know what are the different types of attacking reagents. And now we know what are the different types of organic reactions and which type of molecule will show which type of reaction. So do this in depth. You need to learn this, only then you will be able to write the mechanisms of organic reactions. So these are the basic concepts. So in the next other videos, you will be getting the nomenclature of the organic compounds. And I have also discussed the isomerism in organic compounds in detail. So just go and watch those videos now. And this much is good enough to start going with organic chemistry comfortably. So I think you are feeling a bit better now. So see you in the next videos.